Hello, PLMS. Today we're going to be working with adding and subtracting polynomials. This unit will be from the book, so our I can statements, I can identify a polynomial by its number of terms and degree. Also, I can add and subtract polynomials. So really there's two things that we're concentrating on today. Vocabulary, monomial. You may know that mono means one. An expression that is a number, a variable, or a product, a number of one or more variables. And you can see some examples of a monomial would be just 12y or negative 5x squared because that's all one term. The degree of the monomial, it's the sum of the exponents of its variables. For a non-zero constant, the degree is 0. 0 has no degree. So what we're looking at here is the sum of the exponents if it is a monomial. So we'll have an example of that, but what that's telling us is to add the exponents together if there are different variables. A polynomial. A polynomial is a monomial or the sum of difference of two, it should be the sum or difference of two or more monomials. So a poly means more than one. Standard form of a polynomial means that the degree of its monomial terms decrease from left to right. So you're going to be practicing that today. Standard form means that you're going to be writing the expression where the exponents are going down. Degree of polynomial, it's in one variable, is the same as the degree of the monomial with the greatest exponent. So in this example, it's 3x cubed plus x squared minus 1. That's going to have a degree of 3 because 3 is the greater of the two exponents. So I have x cubed and x squared, so it's a third degree because of the exponent of 3. It's bigger. This chart you will find on page 495. I just want to go through these examples before we do a couple together. In the first example, 7x plus 4, the degree is 1, and it's known as linear. So what we're really looking at that makes it a degree of 1 is that the exponent is a 1. The number of terms, well, it has 2 terms. So the number of terms is going to give it the name. So 2 is going to be binomial. The prefix bi means 2. In the next example, 3x squared plus 2x plus 1, it's known as a quadratic because of the degree. So you could really divide this table into two parts. And so the name using the degree is on the left. The name using the number of terms is on the right. So it's going to always be a quadratic when the degree is 2. It's a trinomial because there are 3 terms, 1, 2, 3. So that makes it a trinomial. You know that the prefix tri means 3. Moving on, cubic. Well, that's going to be 3-dimensional or raised to the 3rd power. It is a monomial because 4x cubed is 1 term. This one is a 4th degree. So after you hit 3, then it just becomes 4th degree, 5th degree, 6th degree, that kind of thing. We notice that our exponent is a 4, and it's a binomial because there's 1 term, 2 terms. In this example, the polynomial is 5. It's a constant. A constant just means a number without a variable. If it is a constant, then the degree is always 0, and it's a monomial still because it's just 1 term. So find the degree of each monomial. Looking at your table, find the degree of each monomial. We would say that 5x is a degree of 1 because the exponent is a 1. Find the degree of 8m cubed. The degree is going to be based on the exponent, so we would say that the degree is 3. This one is a little tricky. 3b squared, the degree depends on the exponent, but in this case, we have a b raised to the second power, but we also have c raised to the first power. And so in order to determine the degree, we have to add those exponents. So we would say the degree is 3. I want to parallel that to this expression instead. If it was 3b squared plus c, then we would just look at the greater exponent because those two cannot be combined. So in that case, the degree would be a 2. So that's just kind of a bonus question. We just learned that anytime it's the degree of a constant, then that's always going to be, you may have guessed it, 0. Name each expression based on its degree and number of terms. And so the first thing I have to do is base this on the degree. Well, x is raised to the second power, and we don't do anything with that because remember that if the terms are separate, then we just take the degree of the higher of the two. So we know that that's a 1, but this is the higher of the two. When the degree is 2, then it's quadratic. And then we have to decide the number of terms. One term, that's 4x squared. 3x would be our second term, and negative 2 is our third term. So we call that a quadratic trinomial. In our next example, we have w squared plus 7. The first thing we have to do is determine the degree based on the number or the exponent. And so that's a 2. We know that if it's raised to the second power, it's a quadratic. And there are 2 terms, so it's a quadratic binomial. Don't you feel smart? Number 3, negative 20. It is just known as a constant. And how many terms do we have? Well, there's just one, so that's a monomial. Some more examples. Write each polynomial in standard form. Now we are going to write these expressions in descending order. It says after we've done that, then we're going to name each polynomial based on its degree and the number of terms. So this is really kind of a two-step process. The first thing I'm going to do is consider I've got a 5 and I've got a negative 2x. Well, the better way to write this would be with the coefficient and variable up front, or an exponent of 1, and then that's a positive 5. So I just flip-flop those, and so now we have negative 2x plus 5. That is in descending order because the x is going to come before the constant. Then we have to determine the degree based on number. Well, it's x to the first, so if it's a first, then that's going to be linear. And then you have to count the number of terms. I've got, again, negative 2x and a positive 5. That's 2. So that's going to be a linear binomial. Could you have done that on your own? I hope so. Let's look at number 2. First step is to put this in descending order. But I noticed something about this problem before I do that. I've got to simplify, and I see that I have a 3x to the 4th power here, and I have a 5x to the 4th power. So I'm going to go ahead and just put those together, and that's going to give me 8x to the 4th power. As far as the other two, I've got a negative 4 and a positive 2x squared. So I want to put the exponent up front and then the constant. So sometimes you might have to simplify before you can write in standard form. Once you have written it in standard form, then we have to decide the degree based on the exponent. We are going to look at the exponent with the higher number, which is x to the 4th. And remember, we just call that 4th degree. And then we have to count the number of terms. Well, I see 8x to the 4th, and I see positive 2x squared. I don't know what this is here. Let me clean this up a little bit. 8x to the 4th, and then positive 2x, and then a negative 4. So there are 3 terms, so it's a 4th degree based on the exponent, and then there are 3 terms, so we call that a 4th degree wait for it, trinomial. Write each polynomial in standard form, then name each polynomial based on its degree and the number of terms. So more of what we were just practicing. I would suggest pausing the video and doing this on your own. Don't forget to name the polynomial based on the degree and the number of terms. So it's in descending order because I've got x to the fourth. Oh, I forgot to write my 2. I've got x negative 9x to the fourth, and then 2 comes after that. So 4 is higher. So descending order or decreasing order left to right was actually how it was stated on the first page of your notes. And then the last one would be negative y cubed plus 3y minus 4. We would say, we don't say third degree. Instead, we say cubic, or three-dimensional, and then it's a trinomial. Good enough. Moving on. Now, simplify each sum or difference. Now we're actually going to get into operations. And just like when we're combining like terms, we want to make sure that it is, in fact, a like term. And I know that it's a like term when the exponent is the same. So number 1 says 5m squared plus 9 plus 3m squared plus 6. This is going to be really easy to do because I notice that I have a 2 and a 2. So all I'm going to do is add my two numbers together. So 9 plus 6, I want to add my constants, and then I want to add the quadratic. So I end up with 8m squared plus 15. It's as simple as that. When you're adding. Now, when you're subtracting, you have to consider that when you're subtracting, you actually have to subtract both terms. So it's just like applying the distributive property. One way to look at that is like you have a negative 1 out in front. So what I would do on this problem is just rewrite it. So I have 2b plus 6, and then I'm going to subtract b, and I'm going to subtract 5. Because once I've distributed the negative to both terms, and really all I'm really doing is combining like terms. If you want, you could put a plus out here in front of it, but it's really not necessary. 6 minus 5 is a positive 1, and then 2 minus 1 would give me just b plus 1 as the final answer. So it's really important when you're subtracting to remember that you are subtracting not just the first term, but the second term, and then combine those terms that are alike. On this example, the last example, number 3, I also am subtracting. If you want to just line up the terms, you can, but I know that I need to distribute negative to all of these terms. Remember, the distributive property is very generous. It wants to make sure that it's passed out to each of those terms. So I notice that this is 6w squared minus 3w squared plus 1. That's my first trinomial. And then I'm going to just line up these terms. I've got a negative w squared. So I'm going to line it up with its like term. And you know what? Before I do that, I'm going to combine terms because I've noticed that I have 2 squareds within my parentheses. So let me go ahead and do that. I want to combine 6w squared and negative 3w squared. And by the way, it would have ended up the same, but this is going to just simplify it. And so order of operations tells us to simplify what's in parentheses first. So let's go ahead and do that. So I have 3w squared, and then I have positive 1. And then I'm going to subtract. You can line it up underneath. I'm just going to line it up because I know this is not going to work out perfectly. So I'm just going to line it up and just keep going, writing horizontally. Negative w squared, negative w. I don't see a w term on the other, in the first trinomial we were dealing with. So I think this is probably a better way to handle this. This is a negative times a negative, which is a positive. So I'm going to combine terms that are alike. I've got 3w squared and negative w squared, so 2w squared. And then I have a negative w, make that kind of a circle, negative w. And then last but not least, I have my constants. So that's going to give me a plus 10. And we want to make sure that our final answer is in standard form, meaning that I've got a squared here, and that would be, W would be to the first power. That is in descending order. I hope you enjoyed your lesson on learning to add and subtract polynomials, as well as classifying by degree and by number of terms. Thank you very much.